Hello everyone, Ismail is here. Today we're going to learn about 15.4 perpendicular bisector of triangles. You can find all the lessons on my website alfaramath.com. Now, the perpendicular bisector of triangles, it's easy more than you think, because you already learned about the perpendicular bisectors, right? So this is the same thing. There is no anything new here except we are using triangles. Try to solve this one up question, and if you have anything, please ask me. First, before we start, you will see that I'm writing some questions. This one here represent perpendicular. So because perpendicular is a big word, so I will just shortcut with this symbol. Okay, so if you see this one means perpendicular, so perpendicular bisector of a triangle. So now just keep it in your mind. So this one is perpendicular, means this one means the triangles. Okay, now we have here an essential question. About the essential question, let's read it. How can we use perpendicular bisector to find the point that is equidistant from all the vertices of the triangles? Means if you have a triangle here, where should be the point? Okay, should be here, or here, or there. Okay, so we need to know which one of these could be the point. If I need to count from the vertices to here, it should be the same distance from here to here, and should be same distance from here. So for sure this point, it's not the same distance, so maybe just from your eyes, so this one should be the same, because this one here should equal to this one, should equal to this one, right? So that's what we are going to learn now, how we can find this point that make all the sides are equal. And also don't forget, we are going to use a circle represent the circle. Now let's go to some definitions here before we start. Okay, as you can see here, definitions. Number one, a circle. Okay, a circle that contains all vertices. So circle contain all vertices of polygon. This we call this one a circumscribed. So circumscribed is a circle that has a polygon inside. Maybe, so as you can see in this circle here, so circle C, okay, is inside a polygon, so we call this one circumscribed. Now in the figure number 2, okay, in the figure circle C, this sign here, as I told you, it represents circle. So if I have a circle, I can name a circle from the point in the middle. So let's say if it's this one A, so this one is circle A. Okay, so we give the name of the circle depending on the point, or the center of the circle. Now in the figure of circle C, circumscribe about triangle XYZ, and circle C is called the circumcircle. Okay, so the circumcircle is just it's the name of the circle, so that has a polygon inside here, so we call this one a circumcircle. Okay, now how about number 3? Point C is called circumcenter. So rather than we saying C is center, we can just also say circumcenter, or you can just say center. Center or circumcenter, same thing, both of them, of a triangle. Okay, but why we call it circumcenter? Because it's the center of the circle, and also it's the center of my triangles. It comes from the center, so that's why we call it circumcenter, because it's the center of a circle and center of a triangle. Now number 4, the circumcenter comes from the perpendicular bisector of a triangle where they are all meet. Okay, so if we draw a straight line from this one here, so this side here should equal to this side here. If I draw a straight line here perpendicular, so this one here, so this one should equal to this one. If I draw a straight line here, so this one here should equal to this one. So this is some definitions and some basic things about what I'm talking about. Now constructing the circumcircle. So as you can see here, let's start constructing the circumcircle. And as you can see here, let me teach you how we can construct the circumcenter from any type of a triangle. As you see, this here is the geometric construction tool. So the first thing that you have to do, just to draw any normal triangle. So let's say I have this triangle here. Okay, let's draw obtuse triangle. So just any type of a triangle like this. So as you can see, this is an obtuse triangle. Now use the compass. Okay, put your compass on one of the edges, then take your compass, open the compass okay, on that line, open it more than the half. So let's say my line, the middle of my line is somewhere here, right? So just open more than the half of the line, okay? Now close this one, then draw a let's say a semicircle, half circle like this, from up and down. Clear? Done. Now move your compass. At the same thing, put your compass on the other edge, okay, and move it like this with the same opening, same setting, don't change. Now draw another arc, okay? So as you can see, I draw another arc until the two arcs that you draw are intersect, as you can see. Now after you finish from this one, let me hide this one. Now connect, take your ruler, connect between this point here to this point here, and make a straight line like this, okay? Now after we made the straight line, now let's construct another angle. Let me change the color for you, okay? Now let's take the same thing, let's put it on other edge, and same thing, as you can see. Let me open this. Now open your compass. You know that the center should be somewhere here, so now your compass should be opening more than the center, okay, just a little bit. Then close your compass, okay, then draw your semicircle like this, okay? So draw the first circle, so draw the semicircle. This is the first one, okay? Now the same sitting, same opening, change this one to another side, okay? Make your pencil like this. Now we draw the other arc. So as you can see here, let's draw the other arc on the other one like this. Clear? I hope it's clear. Now draw a straight line using what we did. So as you can see here, we draw a straight line until like this. Now as you can see, the first line in the black color and the second line in the red color, they intersect at some point. So if you check here in the blue one, so this one here should be my intersecting point, right? So this one here should be my intersecting point. Now from your intersecting point, take your compass, put your compass on the intersecting point, okay? Let me move it here. Yes, now it's on my circle. Now open your compass at the same of one of the edges. So open it like this, or you open it to this one, or if you want to open it to that one. So just choose any edge and open your compass from the points to any edges. Now draw a full circle. So just draw a full circle. See? So now draw a full circle. Now let me hide this. So as you can see here, now the circle, it intersect my triangle from all edges. Now if you want now to see this one, okay, this point here, it's the same distance from all the side. What I'm talking about means, let me hide this one, okay? So the distance from, let's say, this point to the center, it's the same distance from this point to this center. It's the same distance from this point to the center. If you see now, all the green color are equal, okay? So all the green color are equal. So this is how we can construct the line. Now let's go back here to the lesson, okay? 15.4. Now what we are talking about here, this is how we can construct the line. But maybe someone asked me, teacher, okay, you drew an obtuse triangle. Look to these 3 pages. Now if the triangle is obtuse triangle as we did here, okay, this one, the circumcenter, which is the point B, the circumcenter will be outside my triangle. But if the triangle that I draw, if it's a acute triangle, the circumcenter will be in the middle, okay? And if the triangle is a right angle triangle, so the point should be on the triangle itself, okay? I hope you understand this. This is the difference when we have different type of triangles. Now let's look what we get or what we learned from the constructing angle. We learned that the first thing, number 1, so 3 or more lines that intersect at the same point, okay, so we call this one co-current, okay? Okay, so now any lines that, let's say I have a line here, line here, line here, any 3 lines or more, they intersecting at one point, so we call this one as concurrent. Okay, so concurrent is the point that has intersect three lines or more. Okay, number two, that point, it's called point of concurrency. So the point, this what we call this point here, we call this one point of concurrency, when the point is intersecting with three more lines. Now the most important thing is the circumcenter theorem. So what is the circumcenter theorem? Okay, look to this theorem. So as you can see, the circumcenter theorem is the circle center formed by perpendicular bisector. So the circumcenter theorem is formed by perpendicular bisector, and it's equidistant from the vertices of a triangles. Okay, now if I ask you here, look to this shape here. So if I have a triangle and point P is my center, okay, so now from this center to one of the edge, as I told you when we started graphing, this one here should equal from this one to that one here. So also should equal from this one here to that one here. So from the circumcenter to all the vertices, all of them are equal. So if this one is 5, this one should be 5, this one should be 5. If this one 2x, okay, this one should be 2x, okay, this one should be also 2x. So all of these are equal. So this is what you can see, PA, so from P to A is equal from P to B, P to B, also it's equal from P to C, okay. And the perpendicular, so from the same point here, if I draw a perpendicular line to this one here, okay, it's make a perpendicular bisector. So that means this side here is equal to this side. So from here to here, if this one is equal 5, so from here to here should also equal 5. Same thing if I connect a perpendicular bisector on this side here. So if I say this one here is, let's say 6x, this one here also should be what? 6x. Okay, the same thing if I'm talking about perpendicular bisector on that side here. So if this one here it's 2x plus 5, so this one here should be also 2x plus 5. So as you can see here, all the sides are equal if it's perpendicular bisector. Let me summarize this one here. Okay, let me summarize it here to let you understand. Now let's say I have two triangles. The first triangle is this one here, okay, and this point here will be my circumcenter, and the other triangle here, and this point here will be my also circumcenter. Now if I connect the lines here from here to this edge, and from this circumcenter to this edge, and from this point to here, so as you can see here, let me give a letter. So let's say this is A, this is B, this is C. So now what do you think the length all of these three sides? So as you can see, all of these three sides are equal. So PA should equal to BB should equal to PC. So all the three sides are equal. Now if I draw perpendicular things, perpendicular means if you have a line and intersect from the middle, so this one is perpendicular, this one should equal to that one. So now if I draw a perpendicular line to this one here, so this one is perpendicular, so that means this side here should equal to that side, right? So now let me draw it again. So from here to there, so this one is perpendicular. Same thing if I draw a perpendicular to that one here, so from here to here, this one is perpendicular to that one, so this side is equal to this side. Same thing if I draw a perpendicular bisector for that line here, so this one here should equal to this one. So as you can see here, these three sides, okay, so let's say this is A, this is B, this is C. So PA, okay, so not PA. So as you can see here, PA and PB and PC here, sorry, let me erase this one, not B, sorry again. So let's say this is A, this is B, this is C. Now if I ask you PA, it's not equal to PB, it's not equal to BC. So as you can see, when we have a perpendicular bisector, if you look the difference between these two triangles, this one we are connecting from the circumcenter to vertex, okay, but here we are connecting from the circumcenter to perpendicular bisector. bisector. Okay, so as you can see here we make the sides equal. Okay, the sides are equal, but here the sides, there is no sides here. Okay, I can't mention anything about the side. I hope you understand now this. If you have any question, please ask me. Now let's take example to apply what we learned here to this example number 2. Now look to the example number 2. It's saying KZ, so it's saying KZ is and LZ and MZ, all of them are perpendicular bisector. Okay, perpendicular bisector means this one here, okay, this one here, and also this one here, all of them are perpendicular bisector. So that's mean this side here should equal to this one, this side here should equal to this one, this side here should equal to that one. Now let's find now the given thing. So the given information, Zm is equal 7. So where is Zm? So Zm is equal here. So this one should equal 7. Now Zj is equal 25. So Zj is here. So this line here should equal 25. And Hk is equal 20. Hk here is equal to 20. Now let's find Zh. So as you can see here, Zh is here. So from here to this one. We know that now ZH is equal to ZJ because of what? Because of the circle, okay, or let me write it now. Because the circumcenter theorem, okay? Because circumcenter theorem, Zg is equal Zj, so Zh is equal 25 because Zj is equal 25. Now let's find Hg. Where is Hg? So Hg from here to here it's 25, right? So from here to here Hg again. Okay, Hg, it's from here to here. So if we know that this side here is equal to 20, so Hg should be, so Hg is equal 2 times Hk. So 2 times Hk, which is equal to 20, so it's equal 40. Maybe some of you will tell me Hg is equal 20 plus 20, which is also correct. So also it's give you 40. So if you write it like this, or if you write it like this, both of them are correct. Now, let me solve another example here to you. Let me do it again. So as you can see here, we have ZH is equal 85. Where is ZH? From here to there. So this one here is 85. And MZ is equal 13. MZ here is equal 13. Okay? And HG is equal 135. HG, all of that is equal 136. Now, let's find the first one here is Kg. Where is Kg? Kg, it's starting from, sorry, let me erase this one. So Kg, it's starting from the middle to this one. If I know that the green one is 136, so Kg is equal, Hg is equal 136. So Kg is the half of the distance, so 136 divided by 2, which is equal 68. Okay, so now here is equal 68. Now how about Zj? Zj, it's start from here to here, and because Zj should equal to Hz because of the circumcenter theorem, okay, because of this third, so Zg should equal 85, depend this one also 85. Okay, let me solve for you let's say this question here. Okay, in AB triangle ABC, angle ACB is a right angle. Okay, so ACB, so from this one here is a right angle, and D is the circumcenter, so this one here is the circumcenter. So that means circumcenter, so from here, from this side to this side, it should equal from this side to this side, also should equal to this side. So because we know that the circumcenter distance to all the vertices should also always be equal same. Now if of triangle, if CD is equal 6.5, CD, where is CD? So CD, this one here, is equal 6.5. What is AB? So he needs the total angle. Okay, we can say that because, okay, this is easy question, because let's say because D is circumcenter, okay, so AB should equal, sorry, not AB. So we can say that AD is equal, BD is equal, CD. So all of them are equal. So if CD is equal 6.5, so for sure BD should equal 6.5. So for sure also AD should be 6.5. And he asking for the total length. If this one 6.5 from here to here, so from here to here also 6.5. So we can say that AB is equal 6.5 times 2. So 6.5 times 2, which is 13. So the answer is 13. Okay, one more last question for you here. Let's use this question. So last question number 7. Let me solve you question number 7. Given AZ is equal 85. AZ, where's AZ? So from here to here is AZ, which is equal 85. If I ask you which sides also equal 85, this one here is equal also 85. Also here should equal also 85. Now let's continue. EZE is equal 51. So here from here to here also is equal 51. Now find BC. So we need to find BC. So from here to here. We know that if it's giving me hint, use Pythagorean theorem. Now if you look now to this triangle EZC, let me take it here beside. So EZC, this is a right angle triangle, right? EZC. And this one here is given, which is 85. This one here is given, which is 51. So now can I find this missing angle? Yes. So let's say this one here is A. Okay. So now to find A, we can write C squared equal A squared plus B squared. So C squared, we know that the hypotenuse is 85. So 85 squared plus A squared plus B, which is 51 squared. Now, if I need to simplify this, 85 squared is equal 7,225 equal A squared, which is equal 2,000, sorry, 2,000, what's wrong with this? Okay, sorry, 2,601, okay? So this is the answer for this. Now let's simplify this one. Take this, let's isolate A. So we need to minus 2,601 minus 2,601. So you cancel these out. So A squared is equal. The answer is 4,624. Now use the square root for both sides. So now let me write it here. So A is equal 68. So now if you know that this side here is 68, so from here to here is 68, so for sure the double will be, so now BC is equal 68 times 2, which is equal 136. I hope you understand this one. If you have any question, please ask me. Now let's go to the last part here. So the last part, we need to graph a triangle with the given vertices and find the circumcenter. Okay, now this part here is the easiest part in the lesson. First thing, all you have to do is just to graph a triangle with the given vertices and find the circumcenter of the triangle. Here, as you can see, we just draw first and always what you have to do, just draw. First, plot the points, the coordinates. So the first coordinate here is given -6 and 0. So where should be the -6 and 0? So the -6 and 0 should be -6 to the left. So let's say this here is -3, -4, -5, -6. Okay. So now -6 and 0, it should be somewhere here. So this one is -6. Now 0 and 4, 0 and 4, so 0 and 4 should be here, then 0, 0 should be here. Now connect between your lines. So I have here some arrows, so let me connect between my arrows. Okay, oh sorry, the arrows cannot be drawn, so let's draw it by my hand. So let's say now connect between the points. So this is the first one. Now go to this one here, then connect between this one here. Now how we can draw, if you remember when we just try to construct, okay, with the intersect of the two lines, so this one here should be my circumference, right? So the same thing here. How can I do it? Just count the steps. Now just count the steps from, so this one here, 1 2 3 4, so we have here 4, right? So the half of the 4 is 2, so just 2 here, just to draw a straight line on number 2 like this. Okay, now the same thing do in the second one. So starting from 0 to 6, so we have 1 2 3 4 5 6, right? So now the half of the 6 is a 3, so at the point 3, just to draw a straight line from here at the 3. Okay, so as you can see here, now the straight point should be, or let's say this one here is my circumcenter. So now if I ask you what is the circumcenter here, just give me the coordinate. What is the coordinate for this point? It's -3 and 2. Okay, now let's do the other one here. Let's graph this one, -1 and 5. So -1 should be here, 5 should be here, right? Then I have 5 and 5, so 5 on the right, okay, sorry, 5 on the right and 5 up, okay, 5 on the right, 5 up should be here, then 5 and -1, 5 to the right, then -1 down here. Sorry, this is -2, so -1 should be here. Okay, now connect between your points. So this one here should be the first one, then here is the second side. Now connect between the 3 sides like this. Now what you should do, now count the steps, then take the half of it. So now 1 2 3 4 5 6, so I have 6 steps, so I had half of 6 is 3. So now move 3 step, 1 2 3, so now should be the half of my line here. So now just draw a straight line like this. The same thing do to the other side. So now 1 2 3 4 5 6, so it's 6, so the half of 6 is 3, so count 3 steps, 1 2 3, so 3 should be here. Now draw a straight line like this. Now here should be my circumcenter. So the circumcenter, what is the coordinate for that point here? It's 2 and 2, so the coordinate is 2 and 2. Now it's your turn. Try to solve or to draw this 2 triangle. If you finish from this, please try to solve also these 2 triangles. And if you finish everything, try to solve this questions exercise, and also try to solve the number 5 and 6 from here. I hope you understand this one. Have a good day and bye-bye.